Hi friends, today I am going to derive active power, reactive power, apparent power developed in a synchronous generator. So you know that this is the circuit diagram of synchronous generator. Eg equal to generator voltage, R equal to internal resistance, X equal to internal reactance, and it is the load connected to synchronous generator. So load may be anything, resistive or inductive, but in this case I am assuming either resistive or inductive load but not capacitive load. Remember, this derivation is applicable only for resistive or inductive load or any combination of resistive and inductive load, but it is not applicable for capacitive load. So if we combine R plus X, we will get impedance Z. Okay, so this is internal voltage, internal generator voltage Eg. So that is angle delta. So delta is nothing but angle between Eg comma Vt. Okay, so that is combination of R plus resistance plus reactance. So Z equal to, we know that Z equal to R plus Jx. So Z is nothing but impedance. So theta is nothing but angle between R comma Z. Okay, that is nothing but terminal voltage. Terminal voltage or voltage across load. Now I am assuming Vt as reference voltage, that is angle 0 degree. So whether it is be a resistive or inductive load, Ia lags Vt by angle alpha. Even though it is a pure resistive load, Ia lags Vt because due to this reactance, Ia lags Vt by angle alpha. Okay, so these are the terminology. Eg equal to EMF per phase, Z equal to impedance. Impedance is nothing but this combination of R plus Jx. Vt equal to terminal voltage. Delta is angle between Eg comma Vt. It is generator voltage comma terminal voltage, angle between generator voltage comma terminal voltage. Theta is nothing but angle between R comma Z. Ia equal to armature current. Okay, now I am going to apply KVL law for this circuit. So you know that KVL law is nothing but voltage supplied equal to voltage distributed across the elements. So here Eg is supplying voltage, so that voltage is equal to this voltage plus this voltage. Okay, so Eg angle delta equal to what is voltage across this, Ia into Z. Ohm's law, V equal to IR. Similarly, V equal to Ia into Z plus terminal voltage. Okay, so Eg equal to Ia into Z angle theta plus terminal voltage. Now what I am doing, I am taking this Vt to this side, it will become minus. So instead of every time writing 0 degree, I am leaving. Okay, now Ia equal to Eg minus angle delta minus Vt by, I am taking this Z comma theta to this side. What will happen? It will divide. This is nothing but basic mathematics, so no need to explain all this. Okay, so finally Ia equal to, we get this big equation. Okay, now so one thing I would like to revise is that if a angle x by b angle y, we can write as a by b angle x minus y. So this angle will be subtracted. If denominator is shifted to numerator, then that angle will be subtracted. For example, c by d angle z, we can write c by d angle minus z because this denominator angle is taken to numerator, though that time it will become negative. Okay, so if we apply this above theory to Ia, we will get Eg by Z angle delta minus theta, because this theta is shifted to numerator, it will become negative. Similarly here, this theta denominator theta is shifted to numerator, it became negative. Okay, what we are doing in this video, we are going to derive apparent power, active power, reactive power. So you know that equation of apparent power is equal to active power plus reactive power. Okay, so apparent power can be written in two ways. S equal to V into I. This is for DC, but S equal to V into I complement for AC. Remember that only V into I for DC, but V into I complement for AC. So here S equal to, what is V, terminal voltage into Ia, armature current complement. Okay, so apparent power S equal to Vt into Ia. What is Ia? This I am going to shift here and apply complement to it. Okay, so what will happen if I apply complement? Suppose a angle x plus y, if I apply complement, what will it happen? A angle, it will plus will change it to minus, minus will be changing to plus. So angle x plus y will be changed to angle minus x minus y. Similarly here, a comma angle y whole complement equal to a angle. So magnitude won't change, only that angle polarity will change. So here plus is there, now it changes. So magnitude won't change, only angle polarity of angle will be changed. So similarly, we is equal to Vt into something, this big equation I have applied complement. What will happen? This theta will changes, minus theta will changes to plus, and plus delta changes to minus theta. Similarly, minus this theta will be changed to plus theta. Nothing but this only angle will be changed. Next, I am rewriting. I had multiplied Vt with this equation. So Vt into Eg angle theta minus delta by z, and this Vt into Vt square by z into angle theta. So this is the equation now I am getting. Okay. So now I am going to revise one concept, that is, if a angle x is written, then we can write a into cos x plus j into sin x. Similarly, this Vt into Eg by z angle theta minus delta we can write into Vt this equation, because now assume a as Vt into Eg by z and angle x as theta minus delta. So if we expand, we will get this equation. Okay. Similarly, Vt square by z into angle theta can be written as Vt square by z into cos theta plus j into Vt square by z into sin theta. This is nothing but this is Euler's identity. Okay. So if I add this, what I am getting? I am getting this big equation. Okay. Now, so if we rearrange the whole equation, we will get this equation. Okay. Nothing but I am rearranging it. See, I wrote j terms separately, I wrote without j terms separately, so I got a equation. Now if we compare is equal to p plus jq with the above equation, what is this p? P is nothing but active power developed, q is nothing but reactive power developed. So p equal to Vt into Eg by z into cos theta minus delta plus minus Vt square by z into cos theta. That is nothing but active power. Q equal to Vt into Eg by z into sin theta minus delta minus Vt square by z into sin theta. That is nothing but reactive power. So see the terminology. So finally, this is active power, this is reactive power, so this is apparent power. So please see description if you have any doubts and comment me. Okay, thank you.